Good morning, grade 9. Today we will continue with chapter 7, geometry. First of all, we will explain a new theorem, which is the Thales theorem. The statement of this theorem is, when two triangles have a common angle and they are parallel opposite sides, we say that they are in Thales position. Then they have proportional sides. Let's clarify this idea. In triangle ABC, if MN is parallel to BC, then AM over AB equal AN over AC equal MN over BC. This is the Thales theorem. Please open your books on page 34 in order to solve number 7. In this exercise, in the given, we have in the opposite figure AB is equal to 8 centimeters, C is the circle of diameter AB and center O, M is the point of segment AO such that AM is equal to 3 centimeters, C prime is the circle of diameter AM, D is a point of the circle C such that BD is equal to 7 centimeters, C and C prime are tangent at A. In part 1, we have to reproduce the figure. In part 2, justify that ABD is a right triangle and calculate, rounded to the nearest degree, the measure of the angle ABD. First of all, we have to prove that ABD is a right triangle. ABD is right at D since it is inscribed in a semicircle of diameter AB. We still have to calculate the measure of the angle ABD rounded to the nearest degree. Then we have to use one of the trigonometric lines, the sine, the cosine, or the tangent. In this triangle, in triangle ABD, which is right at D, we have the measure of AB, which is the hypotenuse of this triangle, and the measure of the side BD, which is the adjacent side related to the angle ABD. If we have the adjacent and the hypotenuse, then we have to use the cosine. Cosine of the angle ABD equal BD over AB, the adjacent over the hypotenuse, equal 7 over 8. Then ABD equal cosine minus 1 of 7 over 8, and rounded to the nearest degree, we get ABD equal 29 degrees. In part 3, the straight line AD cuts the circle C' in a second point E. Prove that BD and ME are parallel, then calculate EM. We have BD perpendicular to AD since ABD right at D. And ME is also perpendicular to the same line AD since AEM right at E, since it is inscribed in a semicircle of diameter AM. We have two lines that are perpendicular to the same third line AD, then they are parallel. Therefore, BD is parallel to ME. We still have to calculate EM. In triangle ABD, we have proved that BD is parallel to ME. Then we can use, in this case, the Thales theorem. Then AM over AB equal AE over AD equal ME over BD, which is the Thales theorem in triangle ABD. We have AM over AB equal 3 over 8 equal ME over BD, which is equal to 7. Then 8ME equal 21. Then ME equal 2.625 centimeters. In part 4, the common tangent at A to C and C' cuts the straight line BD in N. Choose two triangles and prove that they are similar, then deduce that AN squared equal ND times NB. Let us consider the two triangles A and D and B and A. We have A and D equal B and A common angle, and ADN equal BAN equal 90 degrees. So two angles of the first triangle are equal to two angles of the second triangle, then A and D and B and A are similar. We still have to deduce that AN squared equal ND times NB. We have to use the ratio of similarity. We put the two triangles A and D and B and A. We have AN over BN equal AD over BA equal ND over NA. If we take the two ratios AN over BN equal ND over NA, and if we make a cross multiplication, then we get AN squared equal ND times NB. In part 5, let F be the point such that vector dF equal vector dA plus vector dB. Prove that the quadrilateral DAFB is a rectangle. Deduce that F belongs to C. First, we have to prove that the quadrilateral DAFB is a rectangle. We have vector dF equal vector dA plus vector dB. This gives us that DAFB is a parallelogram, and ABD right at D, this is proved before, then DAFB is a rectangle. We still have to deduce that F belongs to the circle C. AFB is right at F, since DAFB is a rectangle. Since AFB is right at F, then AFB is inscribed in a semicircle of diameter AB. Therefore, F belongs to the circle C. Please don't forget to write the exercise in this video or in your notebooks and to review the exercise. Thank you so much for listening.